All right, folks, if you can slowly make your way back to the seats. If you're in the hallway and you want to come back in and rejoin us, you're more than welcome to. We'd love to have you back. So I hope that over lunch you were able to network, reconnect with folks that you know, hopefully get to meet a few new folks as well. And we're really excited to kick back off with our afternoon session. And taking over the MC duties for me for the afternoon is going to be my colleague, Gretchen Pyatt. Gretchen is the vice chair of our Department of Learning Health Sciences. She's the associate chair of education programs. She's an associate professor in learning health sciences and in health behavior and health education in our School of Public Health. She's also the director of our PhD program in health infrastructures and learning systems. And last but not least, the director of the Precision Health Graduate Certificate Program. We have a university-wide precision health initiative that focuses on supporting researchers in bringing their discoveries to the bedside, for which she leads the Education Certificate Program. Gretchen also is an expert in implementation science and has really, I think, informed a lot of our thinking around the rigor with which we need to study how we implement things to do better science to achieve better health. So with that, I'll turn it over to Gretchen. Thank you.
Thanks, Karen Deep. Thank you, everyone. It's a pleasure to be here this afternoon. I enjoyed the morning talks, and I think that the afternoon ones were set up to hear some more great presentations. So with that, I had a couple housekeeping things just to go over. We're going to have, the setup for this afternoon is going to basically be the same as it was this morning. We're going to have a couple talks, and then we're going to have a moderated panel. And we will have breaks in between those. Again, you have note cards on your tables, and those are for questions. So please, as you think of questions, go ahead and write those down, and some folks will be around to pick those up, and we'll use that for the moderated panel. I think that covers the housekeeping logistics stuff. So it's my pleasure to introduce Dr. Barbara Berry. Dr. Berry is an assistant professor of medicine and a collaborative scientist at the Kern Center for the Science of Healthcare Delivery at Mayo Clinic. And Dr. Berry is a human-computer interaction researcher who studies how interaction with artificial intelligence impacts human intelligence, communication, and behavior. She has made fundamental contributions to AI, developed and evaluated intelligent interactive software agents, and collaborated on large-scale implementations of new technologies to improve health and education. Dr. Berry has her PhD in Media Arts and Sciences, in Human-Computer Interaction and Artificial Intelligence, as well as a master's degree in Media Arts and Sciences in Human-Computer Interaction and Wearable Computers. Both of those are from MIT. And she also did her fellowship at MIT as well. So with that, please help me in welcoming Dr. Berry.
Okay, did I do the mic switch correctly? I got the instructions. Thank you for the kind introduction, Gretchen. And I was mentioning to you, Gretchen, just before I came up here that whenever I come to these kinds of meetings, I'm humbled by all the work we have to do. There's a lot of work we have to do, but also inspired by all the sort of interdisciplinary collaboration, all of the ideas that are coming from sort of different areas, and just the energy with which people really want to come together and think about how we can improve medicine in general and using AI, for the benefit of patients at the end of the day. So I'm going to talk a little bit about implementing AI with the human in the loop. First, just an overview of AI, and then a little bit about implementation science in AI. I'm going to go into the details of a case study because that's what I do. I study case studies where AI has been implemented into clinical practice to be able to evaluate it and give feedback. And then I'm going to give 10 considerations for what to look for and questions to ask when a human's in the loop. And hopefully those will be useful, but also if you have ideas to add to that list, of course, I would want to make a larger list for myself. So there are many definitions of AI, but one that I like is from a Stanford report, AI in Life in 2030. And that's that AI is a science and a set of computational technologies that were inspired by it, but typically operate differently from the ways people use their nervous systems and bodies to sense, learn, reason, and take action. And the reason I like this is because it separates sort of the science and the tool. And I study the tool. There are people who study the science. The tool is the application. And also the idea of sensing, learning, reasoning, and taking action, because I think we can all think about that as humans do that. You sense, learn, reason, take action. You think of a child, picking up a ball. They have to sense it. They figure out how to throw it and taking action. And also that AIs are doing that. And that take action part, I think, for us is something that we are very much have on our minds right now in terms of when should there be a human in the loop, and when or if these tools should be automated. Just quick definitions of machine learning. And also for me, I wanted to make a key distinction between human learning and machine learning, and that to date, although people are making a lot of progress on this, AI tools and machine learning, they're not really good at learning from small examples. So when they're being applied, say, to like an orphan disease, we don't have enough data for an AI to be able to make a decision about that or be able to make a recommendation to a provider, for example. Humans are good at extrapolating. Ways that AI is going to potentially impact medicine. This is from Rajkumar et al. Prognosis, diagnosis, treatment, workflow efficiency, and expanded access. And I think workflow efficiency doesn't get as much of a it's not one of the flashier ways that we think about AI in medicine, but really, really important. Thinking about how to manage patients within the system, how payment works. And expanding access and delivering care potentially without a provider visit, which brings the patient into the loop. I'm going to be talking mostly about physicians and clinicians today and their interactions with AI, but a whole other area of work is patients interacting with AI systems to inform their own care. One reason I like that standard Stanford AI definition is that it goes to this idea of how we think about development within computer science of AI tools. Can we do it? Can a computer sense, learn, or reason and take action in a particular way? Then going into translation, should we use that tool? Should there's a clinical trial to be able to say, is this safe? Is this effective? Should we use it? And then finally, which we get to later, is integration. How should we use this tool in practice? What are the best kinds of strategies for adoption and use and to be able to sustain it? As you can see, I wrote to myself, please revise this slide, and I forgot to take that off before here. And the reason I did that, which is like calling me out in excellent, is that this is fake, right? Like I put them in columns. Like, oh, computer science does this part, and translation does this, the health sciences research does this, and implementation science does that. And it's just fake. Like this should happen all the way across, right? People should all be talking to one another across this. Implementation science, I wanted to give a quick definition from Bauer et al. It can be defined as the scientific study of methods to promote systematic uptake of research finding and other evidence-based practices into routine practice, and hence improve the quality and effectiveness of health services. I think everyone or people are usually familiar with the story of it taking 7 years for an innovation to get from bench to bedside. And implementation science is meant to improve the quality of that and also make that more quickly done and evidence-based. Recently, there have been publications about applying implementation science to AI in healthcare specifically, saying we need a delivery science to bring these solutions into healthcare in a more systematic way. And I'll get to that a little bit later in the talk. So in talking about a learning health system, had a lot of discussions with people over the past couple of days about the idea of a learning health system where you have the infrastructure, data, interventions, people using those interventions, and then a feedback loop where that data comes back in and we're able to improve the system in real time. Like it's a dream, right, in real time. It doesn't happen in real time right now, but Bauer et al. Called out that we can have these massive, extensive repositories of information, but if you don't have the strategies to utilize it, you're not going to create system change. You just have a great database, right? And so I've just used that and substituted AI for the data. So we can infuse a lot of AI tools into healthcare delivery at all different points in care. But if we don't have strategies to be able to use those effectively, we're not going to be able to create system change. And I think that's something where I'll probably end on this slide later on, is that often we think about, here's this one AI tool, I'm going to put the one thing into practice. And we don't think that in the next room, there's a different AI tool that's being used. And if you think about something like a diagnostic odyssey process, right, there might be 10 or 15 different AI tools being used within that process. How is the use of the first tool affecting the tool that's being used down the line? So I don't think we have to start to think more systematically about that. Wait, hold on. Oh yeah, I wanted to call this out. I think this was mentioned in a previous talk. I think Dr. Lehman, you mentioned this. The FDA has machine learning practices for medical device development in AI. And they want models to have focus to be placed on the performance of the human AI team, where the model has a human in the loop, there are human factors considerations, and human interpretability of the model outputs is addressed with emphasis on the performance of the human AI team, rather than just the performance of the model in isolation. So this is a principle, and how do you put these principles into action? I think there are a lot of good discussions happening about how AI models work within the context of care teams, for example. I wanted to give a quick example of a project that a group that I work with did a while ago, kind of GPT related, where they took Alexa and they put it into the exam room with a nurse, with a patient who is recovering from Mohs surgery. So it's a surgery for skin cancer where you shave the cancerous cells off, and then the patient goes home, and they have, a huge protocol of patient education that they have to follow. So you built an Alexa with a dialogue system. Instead of giving them a pamphlet, you give them an Alexa. They can talk to Alexa and ask questions about it. So what we found in that study was that the patient was interacting with the Alexa, the AI system, which could potentially be ChatGPT down the line, right, working better. But what the nurse would do, she would be listening to what was happening, how the patient was interacting with Alexa, and then look over his or her shoulder and say, Tylenol. And then it would jump ahead to the next piece of information that it had. So there's a sense of how the providers and patients are working in real time with these AI systems, and what it means to have to guide an AI system that may not be giving the patient the right information at the right time. And I like that example because it's so cognitive, right? The nurse is typing something in while he or she is listening, to what's happening between the provider and the patient. And I think that speaks to attention. And when we think about putting AI systems into care, the amount of attention and burden it can potentially place on providers, but that's also something that needs to happen. Providers being able to correct AI systems in real time, or correct them when they're not doing the right thing, to be able to help them perform better. So here's just a set of human interactions with AI. AI can amplify human capabilities, read more journal articles than a human could. We can have AI data-driven visualizations, which can help with information overload. As I mentioned, humans teaching AI to improve its intelligence. Human monitoring of AI, fail soft versus fail hard systems. It's okay for an AI to suggest something that could potentially do no harm, but you don't want it to suggest something where it could be fatal if it's wrong. And I think that when we're thinking about risk, that line of what is fail hard and fail soft, what is too much of a risk, what is less of a risk, is being debated and changing all the time. AI alerts to provoke action, a human being being nudged into an action as a provider. And then people accepting or rejecting interactions and recommendations, either globally or locally. So here, I wanted to provide a grid of just things that we think about in human AI interactions, things that we measure. We measure, of course, provider, patient, clinician satisfaction with AI tools. We also mention attention, automation bias, time they spend using these tools, how autonomous they are when they're using these tools, cognitive burden. So I just wanted to give a list of these as things that we're trying to do a better job at measuring in real time when AI systems are put into clinical practice. So I wanted to go through a case example from Mayo Clinic. It's called an electrocardiogram AI guided screening for low ejection fraction. We call it EAGLE. I'll call it EAGLE for this talk. And I'm going to talk a little bit about informing implementation. So using that grid that I'm going to revise after this talk, we have the can we do it part of the development and implementation of this tool. So at Mayo Clinic, Dr. Adi et al. Devised a convolutional neural network. It's trained on over 40,000 ECGs. The input is the ECG, and then the output is whether or not a patient may have low ejection fraction, which means their heart isn't pumping enough blood out, to use the colloquial description of that. It has a prospective validation statistic of 0.9218. It's high accuracy in screening. So the answer is yes, we can look at someone's ECG and predict if we think they have low ejection fraction, and which could lead to heart failure. So that's the can we do it. So yes, check mark, we can do it. So should we use it? So for this, we put together a cluster randomized pragmatic trial using with 558 primary care physicians, 181 in the intervention group. And the result of that study was there was an increased diagnosis of low ejection fraction from 1.6% in the control group to 2.1 in the intervention group. So more diagnosis of low ejection fraction was caught in more patients than it would have if we didn't use this AI algorithm. So implementation of this was rocky. This is about 3 years ago, right after Mayo Clinic finally got up and running all on one system of Epic across our entire health system. And we weren't able to put this completely in the EHR when this was. So there was no BPA for this. A provider would get an email that would say, your patient could potentially have low ejection fraction. Here's a link that sends you to the report. Consider this when you see them. Call them actively or consider this when you see them at the next appointment. So that's what I just described here. Let me see. So there's an EHR there's not an EHR notification now. There will be once we finish implementation in the next year or so. Then physicians get this and they say, do I believe it? Is it going to cost the patient too much? And then that feeds back into the system to be able to retrain the AI. So the fundamental question for the kind of work that I do are what are the strategies for uptake and sustained use by clinicians and patients? And the last two we saw in terms of can we do it, should we do it, those are all yes-no questions, with caveats. But this is a more how can we question. And the other thing that I think we need to look at in these studies in general, when something comes out of a pragmatic trial, and that pragmatic trial, we nagged the providers if they didn't tell us whether or not they were going to accept this recommendation and follow the recommendation for the order of an echocardiogram to confirm that result. We would say like, hey, you didn't order the echo, right? Like we would send them a reminder. In practice, once we implemented that into practice widely, how many reminders are you going to send? Are you going to do that? Is it going to affect that 2.1% increase? And then if we are integrating it into the EHR, and that recommendation is coming exactly when the provider wants it and needs it. Previously, we applied it to a cohort. People are like, I haven't seen this patient in a year. This isn't my patient, right? Like that was not the right way to implement this. But now we're thinking more about how do we get that at the right time so it's right before the provider is going to have a next interaction with the patient. It's worth mentioning with this algorithm that a lot of the cases are asymptomatic. So patient feels fine. They don't think there's anything wrong. And then they get a cold call, right? We ran this AI algorithm on your record, right? And we think you have a risk for heart failure is what we're saying, right? Like that's a difficult result for both a patient and a provider. So I wanted to go over the methods that we used in this pragmatic clinical trial to be able to understand how people were using the tool. Mixed methods, quantitative and qualitative. We asked providers why their rationale for not ordering the echocardiogram after they got the recommendation to do so. We had anecdotal feedback from technical support calls, which is so valuable, right? You're understanding right there, like what are the problems in the digital workflow the providers are having with this kind of tool. We had direct communication from leadership and champions from monthly meetings with their staff, right? They would log for us what the issues were. And I think this is a really helpful thing to think about in terms, if you're doing this kind of work. You want to really be able to triangulate the data. You don't want all of your feedback coming from one source. You want your feedback coming from different sources and different groups that are using these tools. We had usage data, and then we had focus groups with high compliant and low compliant care teams, and a quick survey. So for implementation science, we used a set of implementation strategies that were guided by normalization process theory. And as you all look at this, if you're implementing AI in your practices, these will look really familiar, right? Like you want to train providers. You want to be able to have an alert for the result. You want to be able to potentially have a report to tell people how well is this algorithm doing overall, right? If you're a single provider using it in isolation, you want to see how well it's doing overall. Reminders, and that's what we call positive reinforcement. But what we found, and this happens a lot, is, all right, a toolkit. Everybody likes a toolkit, too. Yeah, we're going to give them a whole toolkit. Look, people are laughing. It's true. We're going to give you a huge 26-page PDF toolkit that you're going to use, and people don't use them. So 2 things that we thought were like, oh, this is going to create behavior change, provider training. We don't have any time. They were like, we don't have any time. If you want to show this, at a department meeting for 5 minutes, that's okay. But we don't want a training on your one tool to give us this one data point about one thing. And then the implementation toolkit didn't get used. So we did follow up, and this is what people used, and this is what they didn't use. So the providers utilized the AI result alert, the email that they got. They utilized the reminder. Stakeholder engagement, that's them talking to different people in their department. We had champions within each department who really knew how to use the tool, and I think that's a good implementation strategy that we got feedback on. We had opinion leaders high up in the organization sending emails encouraging people to use this tool and try it out in the spirit of research to be able to help us understand if this would work or not. I think the things to call out specifically here is that we had an AI result. It was a PDF it was a PDF that providers could find. Hold on. A PDF that providers could find in the EHR to give them more detail. One person saw it. One person looked at it. Terrible. It was buried 5 tabs deep, and they got most of the information in the email that they received. So I think that's another thing to think about when you're giving information about an AI tool and you want somebody to take an action. How are you giving that information over time, and what are you assuming they're going to look at it, and what's enough? Do you want all of it in the BPA, or do you just want a little bit in the BPA that then you tell the best practice advisory that then you have people look to a broader report? So to give a little bit of overview of encouraging perspectives from providers, a lot of them could accurately describe what the tool did, what its purpose was, and how it functioned. That it was a deep learning algorithm that would be able to predict low ejection fraction. They talked a lot about the accuracy. Some of them remembered the accuracy of it in the follow-up focus groups. They thought the tool had value to improve care in a couple of different ways. I think one thing that the AI, when it's giving a result, the provider then thinks about that result as something they can show to their patient and use for behavior change. Look, we should send you to a nutritionist also. You're at risk for heart failure and your cholesterol is high, right? So using that as a catalyst for behavior change. The AI tool in general was trusted by providers, and I think trust is a construct that a lot of people are looking at, and I'm not going to really go into it too much here because I think a lot of that was they knew the lineage of the tool. They knew who had developed it. They assumed if we're getting it in primary care and CV developed it, it's been vetted. Problems? Problems. Providers are burdened by point of care integration. Cannot be underestimated. Primary care providers are getting AI algorithms that are the subspecialty coming at them, right? Like from CV, from endocrinology. They're getting all of these to incorporate into their practice, and it can be a burden. Concerned about a cost of TTT echocardiogram for their patients. I think cost of follow-up tests to be able to confirm the AI result is something that providers, they're concerned about cost overall for their patients. Communicating asymptomatic risk determined by an AI tool to patients, I think that's really difficult. If a provider says to the patient, we use this tool, and the patient says, well, they usually say, do you trust it? That's sort of the first question. If you trust it, I trust it. There's that contract. but they weren't sure at what level they're supposed to explain this tool to the patient, and that can get really awkward, right, for a clinician. Like I mentioned, providers were overwhelmed by that, did not use the FAQ and the toolkit. And for some providers, they saw the AI tool, the output of the AI tool was redundant. They were like, if my patient had low ejection fraction, I already know. I've seen them for the past 4 years, like they're my patient. So that's another thing to think about in terms of value of the output of AI tools. Here are some provider quotes that I'll just let you read on your own, but I think I've covered them in some of the things that I've mentioned so far in the talk. And I think we hear a lot, we have a lot of ethics discussions at Mayo Clinic, part of the bioethics group too, about the human touch in medicine and how which patients want that human touch more in their care and which doesn't matter. It doesn't matter to every patient. So we're seeing that in some of the focus groups that we have with patients. Some of them are like, I want the evidence base. If the AI is right, just give it to me. I know that. I want to know that information. I don't need the provider for it. And others are saying, no, I need the provider to be able to see me, talk to me, understand me, explain that result to me. So that's one of the, I think, challenges in the kind of work that we do in human AI interaction and in implementation science in general, that it's really hard to get consensus among providers about these tools in general, and hard to get consensus from patients a lot of the time also. So I wanted to go into 10 considerations for all of you for when the human is in the loop in implementation science and practice. And I'm teasing those two things out, implementation science and practice. The study of implementation is not the same thing as actually implementing the thing, and those two groups have a relationship to one another that's really important, and I think still being defined over time in terms of AI. We have different departments at Mayo Clinic who do those two things, and we have a collaborative process. One that probably is worth mentioning here actually is we have a board. It's called the AI Translation Board, it's interdisciplinary from specialists and subject matter experts from across our organization, where someone can say, here's my AI idea. And everyone looks at it from their point of view and gives critical feedback and advice from everything from the modeling, the data set that you're using, bias, implementation strategies. So at the end, that stakeholder and person who wants to develop this project gets an overall look from different perspectives of what the issues might be for their project going forward. So the first thing to think about is when the AI has an output, what action is the person supposed to take? And in the case of the Eagle project, the provider, we want them to order an echocardiogram to confirm the result of the AI, right? That's what we tell them. That has an effect on the clinician. They might have to do more work. Effect on the patient, they might have to pay more, right? If we're asking them to do an echocardiogram, are these things covered and how are they covered? But then when we talk to providers, this is actually the provider action. It's a lot of things they have to do. They're viewing the report, they're viewing the chart, they have to do the patient communication, they have to order the TTE, they have to receive the TTE result, they have to confirm the diagnosis, they have to review the treatment options. So this catalyzes a whole set of things that often when we're talking about an AI output, we have to follow that chain all the way to the end. And there are really big impacts on clinicians, patients, and the whole healthcare system. So if you can imagine this, suddenly we roll out this AI algorithm, and suddenly the system is burdened with orders for echocardiograms, right? What does that do to the ED, right, when they need to do echocardiograms for surgery? So this is a system-wide way where we're thinking about resources. I think we have to think about that with every AI model that we're thinking about implementing. And with the impact on the patient, a lot of what we think about is the patient-clinician relationship and trust. So a clinician says to the patient, oh, by the way, I think you might have low ejection fraction heart failure. Some of the providers we talked to said, the patient might lose confidence in me that I didn't catch that on my own. Like, why am I calling outside of the visit? There's a dynamic of trust between the patients and the clinicians that this could disrupt if it's not communicated in a thoughtful way and in a timely way. So that's number one, defining the output-action pairing. The second is articulating clinician and AI roles. So in this particular study, the EAGLE study, it was a proactive recommendation. We ran that AI algorithm on all the ECGs for patients that we had in family medicine in our trial. But providers said they might want it as a supportive check if they order the TTE echocardiogram because they think the patient might have low ejection fraction, for the AI to say, I agree, but not tell them in advance. And then some providers just said, why are you bothering me with all of this? Just automatically order the TTE, right? Which we're not allowed to do, right? With the FDA, you need human in the loop. Can't do that right now. But I think that shows the burden. And here's a quote from one of the providers who said that they appreciated the supportive check. And that supportive check in our study was just out of luck, right? That happened, that it was a supportive check. So that's the second one, articulating the roles. The third one is that typically we think that a provider is going to agree and do the action or not agree and don't do the action, right? But there's more nuance there. So there's actively disagreeing and saying, I'm not gonna order the echocardiogram. There's ignoring that recommendation. And there are, of course, ethical issues along with ignoring that information. They might defer and transfer that decision to another provider, for example, CV, cardiovascular medicine. I want another opinion on this. And then as was mentioned earlier today, is there the ability to opt out of use? And I mentioned automation, so to globally opt out. I don't want to use this AI tool in my practice with my patients. We looked at characteristics of the adopters, and those clinicians who most frequently followed the recommendation of the AI tool were twice as likely to diagnose low ejection fraction. And clinicians with less complex patients were more likely to be high adopters. So there's a paper that you can reference here by Dr. David Rushlow et al. From Family Medicine. Another thing that happens with when we try to deploy these tools in practice is just like a lot of excitement, right? Like AI, we're going to be able to take this algorithm and put it into practice, and the providers are like, great, you're going to help me with my job. And then they get an alert like once every 6 months, right? Like, and they don't remember what this tool was. And so I think there's a way to be able to set the expectations around what amount of interactivity is this tool are you going to have with this tool? You're going to be using it daily. You're going to use it weekly. You're going to be using it monthly. And then also, and I know how intelligent is very fuzzy when we're thinking about intelligence. But here, in terms of how autonomous that particular system is, whether it's a rule-based diagnostic, or whether it's something where it's constantly improving over time and getting smarter over time. I think this is one thing that we need to be able to do better, is to set the interaction expectations with providers and care teams. And this also echoes back to the output-action pairing that I was talking to before, how much burden is put on care teams when these particular kinds of systems are put into the care pathway. A lot of times what's underestimated, and I think which is why we need to do more cost analyses of these, is often we have to put more FTE on a project when there's an AI introduced into this project, because that person is evaluating, and that takes time. And should there be people who are specialists, in their department at evaluating the result of the AI that comes out for palliative care, for a consult, for example, or should every physician be evaluating whether or not the AI is doing a good job? So do we distribute the burden, or is the burden on one person, and how do we think about how this impacts training that might be needed and also cost? 6, I think Dr. Lehman, you mentioned the model facts cards. So model facts cards are ways to be able to label AI tools and be able to give people information about when they were developed, what the data sources were, what the target population is, other information about related models. And here I wanted to mention again, like clinical impact to be determined, right? Like a lot of these we're not, when we're putting them into clinical trials, we're not sure what the outcome data is. And the outcome data is a lot of what drives trust and use. One of the projects I'm working on currently, which is funded by the FDA, is thinking about how do we have model facts cards or information that's patient-facing for these kinds of tools? Patient isn't going to be able to understand this. And also, for primary care providers that we're working with at Mayo Clinic, they might not want all of this information or need all of this information. So what is relevant in terms of consumption, not just for the sake of transparency, but I think also for understanding? We can feel good that this feels transparent, right? We're giving everybody the information, but if people don't understand what that means, it's not helping with the meaningful use. That's number 6. So for number 7, this is a BPA for a different project that's looking at medication for heart failure, recommending GDMT for heart failure guideline, GDMT for heart failure for, sorry, I'm tongue-tied for a minute. I'm going to stop and take a sip of water, if you don't mind. Everybody look at that. So providers will be familiar with BPAs. So a recommendation to change medication. And what I wanted to point out here is, in the EAGLE study, we gave provider surveys to get feedback, and we had focus groups. During the focus groups, they're reflecting on actions that they took 4 months ago, right? So we're trying to get data at the point of care without burdening the provider too much. So here you can see in the BPA, there's a reason why they didn't take this recommendation. And I think collecting this information has been so important, not only for giving information for better workflow, but also what kind of data can we use to really rerun that model, to improve that model and to improve the accuracy and performance of the model. And also what kinds of populations this model has been applied to. So if we're saying this isn't relevant to my patient, why, right? We want to know those kinds of answers. So access to information and data collection. Number 8, and this is sort of related. In the EAGLE project, we had just a pull-down menu if a provider didn't order the follow-up TTE echocardiogram. We asked them why. And in our pull-down menu, we had like, oh, this patient already has low EF. This doesn't matter. This is redundant information. Or they already have a normal EF, so this doesn't apply either. Not justified, which was a catch-all in terms of like, this is not appropriate for this patient in terms of treatment. And the patient declined, or yes, even though the TTE has been ordered already by the time you sent me this email. So we had a section called Other where people could add other, and I think just to call out here, these were the cases that were referred to somebody else. 49 were seen as not priority. So I didn't act on this recommendation because this patient has stage 4 cancer. We're not going to talk to them about heart failure at this moment. And then also the need for more information about the patient, which I think a lot of people who are working on these kinds of models are trying to think about. What's the relevant information from the EHR that I'm going to put next to the result of this AI algorithm so that the provider can make an informed decision along with the patient? And then some of these were forwarded, and we called that not my patient. So sometimes people got this recommendation and are like, I've never seen this patient. I don't know who this patient is. So, we gave this information back to the developers to be able to have better application of this AI algorithm in terms of the workflow. Trust in AI systems has been mentioned here, and these were some of the comments by the providers. They trust it because the AI is sort of looking at the ECG signal in a way that they say, oh, it's seeing some things in this ECG signal that I can't see with my human eye. They sort of trust that the algorithm's there and doing something, but not really sure yet. And then, of course, they trust that it will not be perfect. And the only problem is patients paying for false positives. So I think that's another issue with AI algorithms that we're thinking about. If you have a model and it's constantly evolving and getting more accurate, do you reapply it to patients that you applied it to last year? And if there are false positives, do you call them out and go back? Like, what are the ethics around that we're thinking about with implementation of these kinds of technologies? I'm working with a colleague, Jennifer Miller, at Yale as part of the FDA project I mentioned before about the idea of merited trust. So what increases or decreases trust in these kinds of tools by patients and providers? And thinking about like, what are the levers of trust and how do we responsibly use those levers of trust to be able to have patients trust tools when they should be trusting them, and and distrust them when they should be distrusted, or having sort of critical ways of thinking about these tools. So more on this hopefully at the end of the year. We have a literature review paper that we're preparing now to share with the community. The 10th thing is identifying automation bias. So this is something that's well known in human factors, and it comes from aviation. If you give somebody a suggestion, they might review it the first 6 times, and then they're just doing that. They're saying, yeah. They just trust it. So this is one example where a clinical decision support system, not AI enabled, but I thought this was a good example, increased errors by 86%. Like, that's not acceptable, right? So how do we detect and respond to under and over reliance on AI tools? I think understanding that and being able to measure that in a really reliable way, I don't think we have the tools that we need to be able to do that at this point. And then thanks to Jordan, because I took the slide out and then I put it back in over lunch. So those 10 things to think about. For me, the value of that is really being able to inform measurable implementation strategies. And this comes from Proctor et al. Being able to say, okay, we're going to have a best practice alert. That best practice alert, when is it going to happen? How often is it going to happen? How often do people consume it? How does it affect someone's cognitive, someone's understanding of that, the diagnostic tool? So I think this is to say that the way now, I feel like the way now that I'm doing human-computer interaction within implementation science, there's so much room for growth right now in terms of how we collect this kind of data and how we evaluate this data over time, including cost. So these kinds of strategies also talk about who's going to be able to do this work. So a practical example is that providers said, I don't know how to talk to my patient about this. Like, you give me the AI result, you say contact the patient and tell them they may have low ejection fraction. I know how to say you may have low ejection fraction, but they may not know how to say, we ran this deep learning algorithm, and should they be saying that? So what they asked us to do is to put together communication templates. So if we put communication templates into the system and providers use them, does that increase the number of times that a TTE echocardiogram is ordered and completed, or not? So I think measuring these kinds of, and this is not new to anybody in implementation science, not just measuring whether or not providers act upon the AI tool itself, but what is that outcome and how do different strategies affect that outcome that we're looking for. So my takeaway for this talk is to be able to think through how people are or are not in the loop when an AI tool is being brought into practice, and that human-AI interaction and implementation science can be leveraged for systematic research to determine which strategies most effectively translate the clinical value of the tool, with attention to impact on patients, clinicians, and systems. I wanted to say thank you to everyone who has been working on these projects, my collaborators at Mayo Clinic, and beyond. And as a final closing thought, I know that ChatGPT is sort of out in the world and everybody's talking about it, and it deeply impacts human AI collaboration and human AI interaction in a really particular way, and that is that the form that the data is being delivered in seems really reliable. Like, when you read it, it's a conversation, it's a question and answer. And a provider who I work with in the ethics group, he just asked ChatGPT about himself. Like, what do you know about me and Mayo Clinic? Got the specialty wrong. That was not great. It also kind of merged him and another provider, like, together as one individual person. So that was like, okay, how do you tease this apart if a patient is trying to look up the provider that they're going to see, like, they're going to get an inaccurate look at that. And then the third thing that, to me, as a researcher, was, what? Fake DOIs for publications. It's like completely not a thing. You cut and paste it, and it came up as like a blank URL. So just this idea of, with the human in the loop, You know, with the internet, I think you all remember this time where clinicians were like, don't search for don't search for this diagnosis on the web. Only go to these, go here and nowhere else, right? That's where we're going to send you. And now there's, patient advocacy. We want patients to be able to question and participate and have shared interaction with their provider and shared decision making. And it's just really, I think we have to really start to think about those information sources and being able to validate those information sources better. So I wanted to just throw that out there maybe as like chit chat for the break about ChatGPT. But I'm happy to talk to people about human AI interaction and implementation strategies and really just learn from what you all are doing too. Sometimes it's you get an idea from somebody else telling you about a project that they've worked on. So I would love to be connected to anybody who's interested in this area. So thank you.
Thanks. So thank you, Barbara. I think it was a wonderful talk, and it sort of married all of the AI and the implementation science content so well. So we're going to go ahead and take a break, and we will return at 1:10? Yeah, 1:10, and have another talk. Again, you have the note cards on your tables. So please put any questions you have on those, and we'll be around to collect them. Thank you. Okay, so it's my pleasure to introduce Dr. Michael Kim, who is the Chief of Staff at the National Artificial Intelligence Institute in the U.S. Department of Veterans Affairs. Dr. Kim's research interests include the use of artificial intelligence, and he has a research grant with the Center of Artificial Intelligence in the use of diagnostic medicine at the School of am I reading this right? Yes. So let me start again, though. His research interests include the use of AI, and he has a research grant with the Center of Artificial Intelligence in Diagnostic Medicine at the School of Medicine at the University of California, Irvine. Dr. Kim is passionate about process improvement and has a Lean Six Sigma black belt in healthcare management. Dr. Kim's has a background in biochemistry and molecular biology from the University of California, Santa Cruz. His medical doctorate from the Feinberg School of Medicine at Northwestern. And he did a diagnostic radiology residency at the University of California, Irvine, and a neuroradiology fellowship at the Keck School of Medicine at the University of Southern California. So with all of that, he is eminently qualified to do the presentation today. So please help me in welcoming Dr. Kim.
Hi, everyone. Can you hear me? I think I can hear myself, so I think I'm good. All right, thank you. Thank you so much to everyone for being such an amazing, engaged audience and our co-speakers and being invited to come speak here. I'll just go ahead and get started. So some of the themes here we've been talked about before by our great speakers, but applying it in the federal government is a little bit different. So I'm going to talk about what that journey looks like so far. I did want to just talk a little bit briefly what the National Artificial Intelligence Institute is, because I've gotten some of the questions, what is that and what is that role in the VA? And so I'll talk a little bit of overview of the NAII is what we call it, and then I'll jump into some of our trustworthy artificial intelligence initiatives. So then a little background on just why big data and AI has tremendous capability in the VA is because it's the largest integrated healthcare system in the country. And with that big data comes a lot of opportunities, but also a lot of responsibilities. We have hundreds of thousands of healthcare workers. Our imaging database actually exceeds 10 billion. Someone at OIT told me it's actually closer to 70 billion images. Our MVP program is probably going to get to actually 1 million this year. We're around 900,000 and change right now. We have basically facilities in every single part of the United States and territories, with 1,200 facilities and close to 150 full-fledged integrated full healthcare systems. And we serve a large population, close to 10 million. Our vision is to lead the way in trustworthy artificial intelligence, to become a premier global institute for research, implementation, policy, and collaboration that enhances outcomes for our veterans, their families, and beyond. And the NAII is here to establish the U.S. Department of Veterans Affairs as this organization to accelerate trustworthy artificial intelligence, not just artificial intelligence. So talking a little bit about our strategy, in 2000, I think it was around the end of 2019, there was an act that passed. It basically formed the National Artificial Intelligence Institute office in the White House under the OSTP. And with that came the first founding director, Lynn Parker, and many offices across the federal government started developing their version of an AI institute to try to accelerate trustworthy artificial intelligence in the domains and areas of their parts of government. And we worked on an artificial intelligence strategy to know where you're going, and we took a very inclusive approach across our organization to come up with those strategies to promote our trustworthy artificial intelligence. Our execution priorities really, we can't do this alone. VA has its strengths, but we need to partner with academic institutions such as the ones here, and also industry. And how do we do so to form a collaboration to promote trustworthy artificial intelligence deployment to benefit veterans? We must prioritize and actually make investments in artificial intelligence. So we can talk about a lot of mandates that we've been given without necessarily the resources to actually accomplish them. How do we reduce the barriers? We know the federal government can have a lot of bureaucracy. So how do we kind of try to accelerate that process? And how do we have something that really follows the entire life cycle of artificial intelligence? And it's beyond just coming up with a use case, but to govern and monitor and assess that it's trustworthy throughout its life cycle. I'm going to pivot the majority of my conversation on trustworthy artificial intelligence. I don't have enough time to talk about several of our flagship projects that I'm particularly excited about, which after the presentation, if you want to hear a little bit more about some of the larger flagship projects that we're particularly interested in, I'd be more than happy to do so. I'll just name them quickly. One is our digital command center process, which takes near real-time data and integrates it in clinical workflows that you can layer artificial intelligence models in, but it's also scalable for the enterprise. That's one system. And the other one is we're about to get our FedRAMP High ATO on what I believe is the first read-write capable digital health solution through a cell phone that can also layer in artificial intelligence protocols and code into it. We could talk about that. I'm going to focus the rest of our conversation around trustworthy artificial intelligence. I saw the other speakers and okay, this is a theme here. I'm going to go with this. Okay, so frameworks and policy. We saw a lot of discussion on frameworks and policy from our great speakers earlier. And the key one for me, the key one for the federal government is what we call Executive Order 13960. So if you're not familiar with executive orders are from the Office of the President. And when they are signed, they have the force of law in the federal government. Not necessarily the rest of society, but for me, I am federally required to do this. I absolutely have to do this. And there are 9 main principles that come out of this Executive Order 13960. Lawful and respectful of our nation's values, purposeful and performance-driven, accurate, reliable, and effective, safe, secure, and resilient, understandable, responsible and traceable, regularly monitored, transparent, and accountable. Definitely a lot of principles. How you actually implement that is a totally different story. And we're going to talk a little bit more about the many other principles and frameworks that I'm supposed to follow. But an executive order is different because the executive order is the force of law. Okay, we have to remember that. So there are a lot of things that have been happening. We know this is a rapidly changing landscape. There is stuff regarding, I talked about 13960, but we also executive orders on racial equity, 13985. Just about 2 months ago, they made another executive order on advancing racial equity, 14091, that actually had to adjust other executive orders. So I mentioned 9 principles in EO 13960. I now have an asterisk of a 10th. And I need to show my 10th equity principle. How to make sure that the trustworthy artificial intelligence are equitable. We heard earlier about Blueprint for an AI Bill of Rights, which was discussed and really important. And I think what's particularly interesting about that one is they really kind of highlight, in distinction between 13960, is this human fallback isn't explicitly mentioned in the other guiding documents. And notice an explanation. While we say transparency is a principle, that notice and explanation really is articulated strongly in the Blueprint AI Bill of Rights that we will talk about more later. Other documents we have to follow, also published in the Federal Register, is the VA Principle of Ethics-Based Framework to Access and Use of Veteran Data. We heard about the NIST AI Risk Management Framework. The GAO has their own accountability framework, and then there's also other documents, including from the EU and the OECD, that are often referenced, so I mentioned them here. What happened? So that's a lot of frameworks, right? That's a lot to process. And it almost seems like the next day, there might be another framework, right? Like Chai is a great framework. I loved it. It came out a few weeks ago. But it's like, what do I do with all of these frameworks? And what are the common themes with all of them? So we actually tried to do a fun little AI thing on AI frameworks. We did a hierarchical clustering analysis. Like, what are the common themes in every one of these frameworks? And how do we actually take that to actually say, what are the common themes that we can say apply to all these great principles and frameworks, and use that to maybe perhaps define a singular framework that can work for us in the VA. And this is a very busy slide. I'm not going to read all of it, but I list many of these guiding documents that I'm accountable to, and then use that clustering analysis, apply qualitative and quantitative techniques to see what were those themes, to kind of create our pillars and our true north for the NAII at the VA. And we went and developed, you can read them at the top, purposeful, how does this actually benefit veterans? How do I make sure that they actually work and are safe to treat veterans? Are they security and privacy? Obviously a common theme in almost all the principles. Fair, but not just fairness, highlighting equity as part of that aspect as well. Transparency, explainability is a common theme, and we paired that. And also some continuous monitoring and some person that's actually responsible for that system. We need to know that who's responsible. So right now, this is the actual framework we've adopted, taking all the existing principles and frameworks preceding it. And this is our current framework at the VA National Artificial Intelligence Institute, and allows us to align many documents. So the White House comes up with the Blueprint for a Bill of Rights, or this is Executive 14091, or this 13960, and I'm talking about this alphanumeric soup. Like, I know that I'm going to hit all those bases if I follow these 6 main pillars. And this can also be usable and adaptable for different offices, because every office in VA is a massive organization, may need to be accountable to this, and there needs to be a higher level of framework that they can apply for their own areas of governance. So most of my career has actually been in operations. I really sympathize for frontline nurses and doctors, particularly because I was really in charge of running COVID-19, and I saw their plight, and I saw the burden they actually deal with every day. And when I tried to find my unique role is bridging national policy and frameworks to be actually coherent and usable by the front line. And somewhere in there is middle management. And that's where it existed a long time in my career, was middle management, like, you know, running a healthcare system. And I can have all these frameworks. I can have a framework for frameworks. But at the end of the day, when does the rubber meet the road? How do we actually develop pilots to test this on how this could work? And how do we test it at one VA facility, then maybe 4, and then possibly develop a framework that can work on a sustainable, scalable, and a repeatable across VA? So you got to start somewhere. I'll talk about 3 different pilots we've done. One is, I wouldn't call it Belmont 2.0, which was mentioned before, but how do we perhaps, and this is very controversial, I've really upset some like research people with this, but we created a specific questions that address the unique risks that AI introduced, and made a supplemental module to complement, you know, your standard IRB processes. Another, we heard earlier about model cards. How do we actually force and function, not just say this is the theoretical application, how do we actually implement and test it in the field? And further that, how can we adapt model cards to be patient-centric and also perhaps a model card version that depends on the audience you're trying to hit with that. And lastly, research is just one domain. We know that there's quality improvement in many organizations. This is not IRB, human subjects research, and then what happens to the governance of that we don't know. A lot of healthcare systems, they never see it. There is no governance, and some systems do have governance. So we'll talk about an overarching AI oversight committee pilot that we did at a facility. So the AIRB pilot really had two phases. One was really just like, how can we even try to adopt these principles? How can we use it to complement existing well-established principles of data of protection, that human subject protection that IRB has? So how can we complement it? And then where you take lessons learn from that to make it better, iterate, improve, and scale to multiple NAII centers. So let me talk through that. So we got a cross-functional team together. We reviewed all the principles, and we came up with questions we thought would augment, not replace, the underlying processes in the IRB. And I'm not going to read all of these things verbatim, but we looked at each principle: AI Bill of Rights, Executive Order 13960, our Trustworthy AI framework, and we said, how do we articulate questions that help stimulate thinking on unique risks of AI in this research project? Well, one, you need to know whether AI is being used, right? So first of all, so very foundational questions. Talk about the data sets. Could there be bias? Is this representative of the patient population you're looking to serve and develop a model? What about benefit for veterans, right? We've had the few cases that I'll talk about, use cases that we blocked to protect veterans. But some of them were industry-sponsored trials where it kind of just felt like a big data sweep. Industry wants to come in, they're not being very transparent, they want to collect a bunch of data and not really tell us what they're going to do with that data. That seems to be I'm going to say it's a common theme, but that's where our protections have been the most effective. So talking about whether, particularly for industry-sponsored trials, what is the veteran getting out of this? What is VA getting out of this was an important question we wanted to ask. Where privacy security, where is this data actually going to be housed? Is it a local instance? Is it the national cloud-based server? What do you plan on doing with this? And who are the stakeholders? Who's actually going to be using it, right? Because sometimes you just have a model. Like in this implementation, the great talks we had on implementation, who is this really to serve? Is this patient-facing? Is it frontline-facing? Who are the actual users of the system? Articulate what actual clinical decisions, if they're clinical decisions, are going to be done, and to explain what the limitations may be and what the risks may be, and to start articulating what your fallbacks may be. And then one is to have them self-describe in this kind of linear scoring system of full human oversight to completely autonomous. Where do they see their model falling under? We did it. It was just these open-ended questions, got a lot of complaints, but we actually had an interesting story that happened, literally a month after we tried this pilot, just at one facility. And there's 140 facilities. There was an industry-sponsored trial at VA Long Beach, where I was based at, and it was to do, it was basically a biomarker type study. They wanted to collect a bunch of radiology data, EHR data, lab data, path data, blood data, and they basically are going to use FISH to see if they could predict if someone can get a lung cancer. And that was basically the story. But when we actually dug a little bit deeper and went through this exercise of these questions, we're able to solicit some kind of discovery that there were some major concerns with that. There was no mention that the intellectual property was actually developed using AI. There's no information how the subject data would be used to refine the AI algorithm. The informed consent, it did talk about them collecting blood specimens for genetic testing that may be used for future use. It wasn't included in the study protocol, and it was indefinite use, and it wasn't really clear how they were going to use this data, when they were going to use it, for what purposes, almost as like this biobanking that they were doing. No mention that the intellectual property was going to be used with AI. No mention of how clinical decision would be impacted using this AI. So whether this pilot made a big difference, it's unclear, but in the instance of this pilot, it did seem to make a difference. And we should also remember that, and we heard this earlier, it was the conversation that, large tertiary top medical centers, like with at University of Michigan, you guys are amazing at data science, right? You could probably detect the ethical issues here quickly. Remember, V has 140 medical centers, right? Or think of that community hospital. Like having toolkits or advisories and helping smaller facilities navigate this is something to think about, because it's not necessarily every day that every facility in this country is going to have the same level of skill and resources as Michigan Medicine or Duke or Brigham. And that's just the reality of it. So our lens of deploying this is something that could be used by the field as a toolkit, as a support tool. And yeah, it seemed to make a difference. So we went with that success, and we moved forward to see how it would work at 4 facilities. And we actually tried to make a version 2.0 of this. Well, one, we got user-centered feedback. The IRB complained that we don't do open-ended questions. We do structured format, yes, no, checkboxes. We don't do that, okay? So, okay, got you. The next was, can we improve transparency and try to incorporate communication through improved language and informed consent, and also through actually deployment of model cards in our pilot. What happened? Okay. So we took those initial questions and we put it in a more IRB structured format. And a lot of them talk about exactly what I mentioned earlier. It's just in a much more IRB friendly way. I'm not going to read all of these because we kind of talked about them already. What we also did is, we heard earlier about model cards, and actually implement them, not just talk about them. So I didn't know the audience would be familiar with them. They're kind of like nutrition facts, what's under the hood. And we basically said that we're going to deploy these in every AI IRB pilot site for these 4 facilities. So you're going to have adapted language specific to informed consent. You're going to have to use the structured form for the IRB pilot, and you're going to have to develop a model card for them. Well, then someone asked, well, if informed consent is the key aspect of Belmont and IRB and communicating with patients, is this model card really going to work for having those communications with patients? And the answer was no. So we tried to experiment developing more patient-centric versions of the model card, something that is, 8th, 9th grade reading comprehension, use more simplified language, and that's really, really hard to try to explain AI in simple language. I'm not saying we got it right, but at least we're trying, right? Who can you contact if you want to learn more? Just a very layman's perspective on what artificial intelligence is, what are the clear objectives and purpose of this study you're enrolling in. And this is a template we developed to also be incorporated as part of this pilot to try to amplify and improve transparency and explainability for patients, not just for us. This is still ongoing work, and but during this whole time, I'm thinking in my head, a lot of the projects I want to do and then I'm involved in are quality improvement operational, and this is research. How do we govern operations and quality improvement? So we kind of came up with the workflow. Okay, so the first decision point is this research or not? That's something under the expertise of the Human Subjects Protection Program. And if they say no, then it just isn't like indefinitely disappears. It has to go somewhere. And we created an AI oversight committee that will be a catch-all for all AI use cases, whether they're vendor, biomedical devices, whether they are research, whether they are quality improvement. And that pilot is ongoing. I'm not going to read this, but it's the same concept. How do we take these principles, and are they different if they apply to medical devices that are deployed in the field? Is it different if it's quality improvement? It's the same concept. Are we making sure that we hit every principle that we want to hit in our Trustworthy AI framework or the executive order, whatever your true north is, if it's the CHI or Like, are you asking the questions to help augment, to understand what's under the hood? And do they differ depending on different work streams? Because the challenges for research might be different for operations, might be different for something that's FDA approved. And I can share the slides. I think they will be public available. You can read through them. If you have any questions, you have any suggestions, please. So the part of this is just us trying to experiment and see what works and learn from that and try and improve. So 3 pathways: IRB, QI, and contract procured solutions. And in the facility I was working at VA in Long Beach, we actually developed the first real policy to actually enforce these principles that we talked about earlier as requirements. Because medical center policies from a healthcare system level, are more serious. Like, it's not just an advisory. This you actually have to do. And I think, from my understanding, this is the first medical center policy that has been charged with the oversight of AI in the entirety of VA. At this facility, the director is accountable, actually, and the director is the CEO of the facility. It defines who is in this subcommittee. I'm not going to get into the charter and the membership. It's what you would think. It's cross-sectional, data scientists to ethicists to security officers, et cetera. I did want to highlight a piece of the oversight policy on what is actually required, right? Because what actually is required is going to be meaningful. So there will always be an inventory of all AI systems, period. Okay, so you can't oversee anything unless you know what you're overseeing, right? So there is an inventory that's required. This team will be charged for a risk assessment of those devices. And this is important. I put it in bold. I know there was controversy there remains controversy around human alternatives consideration fallback. And for us, we said, when available and practical. And it's going to be situational dependent. I don't think every AI use case will always require full human oversight. I think you're going to have to do a risk assessment, and you're going to have to make a decision based on that. But the notice and explanation we did capture. It is a medical center policy that you have to have a model card available for staff and patients if an AI system is being used. And this is an experiment we're trying. We see how it goes. But that's been kind of what the journey is, because I encourage it for everyone. Is like, we've had these great conversations of us having to make a difference here on trustworthy artificial intelligence. And you guys are, but I really encourage you to actually test and see, how do you actually make this work and learn from it and iterate from it. And that's the approach that I'm trying to lead right now is let's go experiment, let's try. Because I think some oversight and some governance is better than none, and just talking about it from an intellectual standpoint. So that is probably the conclusion. I am probably way early. I went really fast, I think. Am I on time? But anyways, no more slides. I don't have any backup slides either. So I think that'll do it. Thanks.
Thank you. And that's okay that you're early. That just gets us out of here sooner, right? So we're going to go ahead and take a break. We could do another 10-minute break since we're about 10 or 15 minutes ahead of schedule. So let's do a 10-minute break. Please use the note cards on your tables, again, to write any questions down that you might have, and we'll be around to collect them. And when we come back from the break, we're going to go ahead and do the moderated panel with our speakers and an additional guest, Dr. Akbar Walji. So we'll see you soon.
our panelists? Yeah. For the first panel earlier in the day, we had some panelists talk all night every time, whereas others got inverted, so that they were off, and I thought they were off. Okay. So we're going to ask this time the panelists leave the green light on and don't touch it. Or like, only don't bother with it. Sounds good. Panelists sit down as well. But we just want to leave it on.
Sounds good to me, yeah.
It's easier. Less potential for getting cut off by one error.
Right.
Right. Because we had some of our speakers literally turning it off right before they
Okay.
and then turning it back on. Okay. When they're done. All right. So I just want to make that easy.
Okay, sounds good. Thank you. Yeah, I think so.
Shut that off. This is our last slide today.
I think we're ready to go again. Everyone, we're going to go ahead and get started again. So if you could take your seats, that would be great.
So we're going to leave the fantastic throughout. Yes. So we'll just leave them green light. So we will be keeping the mics on throughout, so don't bother with the button.
Okay,
Just aim
sounds
it at yourself as you're trying to talk. It has a pretty tight cone of hearing, so if it's pointed at your voice, your voice is pointed at it.
Mike.
So I'm not certain if you heard, we're leaving the mics on through the whole panel, so don't bother with talking.
Oh, okay. Don't touch any buttons.
Don't
Okay.
talk to yourself.
Don't talk. Okay.
All right, thanks everyone. Thanks for coming back promptly. So we're going to go ahead and get started on our final talk / panel of the day. And with this panel, you've already met Dr. Berry and Dr. Kim, but I want to also introduce to you Dr. Akbar Walji, who is the Lyell Roll Professor of Learning Health Sciences in the medical school. Dr. Walji is an accomplished physician scientist in healthcare policy and innovation, focusing on using machine learning and deep learning techniques to improve healthcare outcomes. Akbar holds several leadership positions at the University of Michigan, including serving as the faculty lead for the IHPI Data and Methods Hub and the co-director of the Michigan Integrated Center for Health Analytics and Medical Prediction, which we call MyChamp, as well as a convener for the eHealth and Artificial Intelligence Program, which we called eHealth. Akbar's work is aimed at improving healthcare access, quality, and efficiency, particularly in resource-constrained areas. So let's welcome Akbar. So we'll do the panel similarly to what we did this morning. A lot of you submitted questions, which I have here, and some of them are specific for specific presenters, and others are more general. So I think what makes some sense is to maybe do a little bit of the specific ones first, and then we'll open it up to the whole panel. So a question here for Michael. How much does the VA's transition to Cerner affect the VA strategy with respect to implementing AI?
Can you hear me? Okay. Well, whenever we pick up a new project, we ask whether it's possible, whether I believe the vendors or not. That's a different story. For from what I know of our health informatics infrastructure is that I do believe them because a lot of the back-end systems, like we're going to have a central data warehouse. We're going to have a system called Vista Millennium, which is basically going to be a large repository for clinical informatics storage that will be agnostic and help bridge between CPR's Vista to Cerner. So I'm not too worried about it. I'm more the concern. I mean, there are going to be bugs. I mean, there are bugs today we can read about in the media. But I'm not going to go into that topic specifically.
Okay. Here's a question for Dr. Berry. Do you think, so for the results that you presented on the ejection fraction model, do you think that you would have seen similar or dissimilar results if it had been implemented in a low resource setting and not at Mayo?
Yeah, that's a good question. So I think two comments on that would be relevant would be, in terms of resources, there's, how to say it, I've worked in low resource settings before, and often what happens in those settings when you bring in a new innovation, it's a small pilot, and there's an expectation that small pilot happens, and then the small pilot grows. And often those kinds of projects, they don't grow. What happens is somebody does a small pilot, then the next small pilot comes along, and then the next small pilot comes along. I think in terms of resources, we could do a large-scale pragmatic trial. That's because there were 153 different care teams that we could go to, and they were paid as part of their job to work on this project. In a lot of low-resource settings, it's not, because we're an academic medical center also, that has an influence on this. Part of our jobs is to work on research and how research can impact care across the board, because we have medical school, education, research, and practice. A lot of lower resource places don't have that. It's just the contract of the way that the place works. So if anybody's doing it, it's on their sort of their own time, put it that way. So to me, that's the biggest issue. And also, I mean, these kinds of systems, they're expensive to create and they're expensive to maintain. And one of the limiting factors that I think we were talking about the other day was who's going to own this at the end of the day, right? Like you get it, you work. Who's going to own it? Who's going to shepherd it through? Who's going to maintain it over time? And oftentimes that's IT. And I think in our organization we said, well, who's going to own and maintain? Is it CV that owns it and maintains it, or is it IT that owns it and maintains it for CV in primary care, or is it primary care? So there are all of those kinds of discussions where in low resource, they're not discussing who's going to do it, they're discussing where do we get the money to do it.
Right, and who does it belong to once it's implemented? A question I had that sort of followed up on that was, in the sample of providers, were those all primary care providers, or were there also specialists in there as well?
All primary care providers and nurse practitioners.
Okay. Akbar, do you want to say anything about the under-resourced areas topic?
Yeah, I mean, I could say a lot, but you know, part of this is, I struggle with saying to myself, one of the slides that Mike put on the whiteboard there was all these potential regulations, right? And we're saying to ourselves, it's going to take 7 years potentially to get something out like this into practice, but there potentially is a need now. Right? There's a need now, and how do you balance that risk of that assessment of these models with what can be deployable and potentially usable? And a couple of the examples that I shared with others, and maybe this is going longer than I should be, but I'll just demonstrate to you why I think there's value in deploying some of these models sooner than later, is to say, the risk, for example, of colon cancer in the United States among 45-year-olds and higher is as high among the 20 to 30-year-olds in Africa. Right? So there are people dying in Africa of potentially colon cancer in their 20s to 30s. But our clinical guidelines say you have to have a colonoscopy. Right? This is our clinical guidelines that sometimes low middle income countries emulate. Right? But there's one endoscope per 100,000 people there. Right? If you don't do something about that now, then where potentially the risk here is like a 50-50%, and we can develop a model that's better than that 50-50%. Is there opportunities to deploy this sooner rather than later? Similarly, a VA example is, in 2015, we had these amazing hepatitis C drugs, right? They were $100,000, but they would cure you of your hepatitis C. Hasn't been a drug like that in a long time. But they came at an expense of $100,000 per patient. Now we have 10 million veterans, 250,000 of them have hepatitis C. So 250,000 times 100,000 is $25 billion. That would bankrupt the VA, right there. That would also mean less money for PTSD, less money for traumatic brain injuries, less money for amputees. So how do you actually go about potentially utilizing models that could direct care to those that need it the most? And we talked about this before. The VA is an interesting community, right? They're very altruistic. A veteran will forego their treatments for someone else who's sicker, right? So why not deploy some of these models that risk stratify patients who are sicker? Right now, you can imagine me being on CNN saying, Dr. Walji creates a hepatitis C model that risk stratifies and triages veteran care. That's going to be a problem, right? Because I'm already triaging care. But we started a different aim. We went actually to veterans themselves and said, imagine you were a policymaker. Imagine you were a decision maker. How would you do this? And all of them unanimously said, if you have the money, please pay for it. But if not, then risk stratify and treat those that need it first. Remember, clinical care currently is also stratified. People come in for their care who are more caring for their care. So they may get the hep C treatment. But are those the people that need it the most compared to those that are actually not seeking care? So a risk stratified model could be beneficial. And so just thinking to the process about, yes, it's going to take a long time to deploy these models, but there are potential opportunities to do that in a low resource context that may be more meaningful. So anyway, a long-winded answer, but yes, sorry.
Thanks, Akbar. So I'll go on to move to a question here for Dr. Kim. The question was, are there standards or specific details on what should be included on those model cards that you showed?
I can share it. There is a template that came from the GSA service that we adopted. It met all our requirements. It looked actually very similar to, I think it was your presentation. Yeah. But yeah, I'd be happy to make it available. We have a prescribed template. It talks about everything.
So here's a question. I think we'll do the remaining questions are more for the whole panel. So to the panel, whoever wants to start us off. Since we heard this morning that really the deployment stage of these AI models seems to really be like the linchpin in implementation. So the question here is, given that barrier, are any of you and your teams working with implementation scientists as part of your teams?
Well, it sounds like you are an implementation
Yes.
scientist.
Yes, I am. Just speaking about implementation science in general, science in our research shield. So we have an education shield, medical school, et cetera, professional development. Practice shield, that's where all the care happens. And then a research shield. So we had implementation scientists in our research shield. That was about 5 years ago. Now there are implementation scientists in our Center for Digital Health, which is the digital implementation arm. Those are the people who implement the stuff in the clinical practice. We have implementation scientists in the group that I'm in, which is in the Division of Healthcare Delivery Research. We're a research group that works in the practice. So the Center for Digital Health will come to us for advice. And then there are also implementation scientists working in the research shield also, in epidemiology. So there are sort of more of us speckled throughout the organization, and people like me who I consider to have like a kind of minor that I'm gaining as I'm doing the work in implementation science. But there's definitely a gap, and I don't know if you could potentially speak to this question. The gap is that we have people who are implementation scientists, but we're lacking in people who are implementation science facilitators, people who will work with in the field with people who are implementing these to really teach, like, what data do we have to understand to be able to know that this is happening? How do we really have that climate ready? How do we gauge readiness for this implementation? So that kind of collaboration, I think, is still evolving.
Any other comments?
Yeah, so at the NAII, I'm in the process of recruiting diverse different type of talents, from project managers to ethicists to implementation scientists. So we're working on that. We know that's a key piece. That's what this whole forum is about, because it's one thing to come up with the framework, it's another thing to implement it. It's one thing to come up with the model, it's another thing to implement it. That's where the rubber meets the road, and so much work needs to be done in this space. And so we're internally trying to address that need. We're also are a collaborative organization. We realize we're not the only people with equity in AI. There are a lot of different offices, from specialty care to HSR&D to query. There are subject matter experts everywhere. So we try to collaborate extensively throughout VA to get what we need to accomplish the mission. So, so internal and also through collaboration.
Great, thanks, Michael.
Similar, working at the VA, we have a strong, robust, at least in Ann Arbor, an implementation group that's a lot of the faculty in the Department of Learning Health Sciences. But even within VA, we have, sort of the implementation operational groups that work together. Interestingly, it's important to also recognize, who are sort of the implementation scientists, and like you mentioned, sort of those engaged with the implementation scientists. And in the context of, sort of the work that I do in East Africa, it's sometimes the community health worker in conjunction with the community that are the effector arm, right? It's the community that should be the ones that are engaging in the sort of the implementation science work. And I think that's sort of a learned lesson from that.
Yeah, 100%. I agree with all of you. I think to Barbara's point about, the implementation science versus an implementation, say, specialist or some derivation thereof. An implementation scientist is really someone who is studying the science of implementation. So, we're asking those research questions and trying to figure out, how is this working? Why is this working? And then adapting. But an implementer or implementation specialist is really the person who's on the ground, in the clinic, in the community, in the organization, who's actually doing the stuff that then the implementation scientist is studying. And I think that that's a distinction that we could probably be better about in the field. And a question that sometimes we sort of pontificate about a little bit in our department is, what would it look like if each clinical department over here at Michigan Medicine had an implementation person? I mean, not even so much as implementation scientists, but someone who was dedicated to implementation. I think that it would look a whole lot different. And a lot of the initiatives that, we carry out through research would become more applied, more of an everyday type of activity that happens. Okay, so let's move on to another question. So this one says, as the U.S. healthcare system is transitioning to value-based care, is the integration of AI in healthcare actively considering how it will follow this trend? Or is there active planning for AI in healthcare in making it accessible to all? And I'll just open that up to anyone who'd like to tackle that.
That's a big one.
I mean, I think all health systems are trying to think about how to utilize AI in the best and most efficient way. Everything from, optimizing your clinical notes, right? You can imagine, and Brian can speak to this because he's a leader in the health system here, where they've been, talking about how can we have, for example, ChatGPT respond to your inbox. I don't think that's a good idea, but that's a possibility. How do we actually maximize, the revenue and a billing on an encounter note so that you're actually, maximizing revenue coming back? How can you use it for clinical simulation education? I think we're thinking through all those domains right now. And the question is, where's those high-value care that's acceptable and risk-assessed, in order to deploy?
Anything additional?
I would just echo that a lot of the work that we're doing is about identifying a way to get the right care to the right patient at the right time, to make sure that sort of the competition for resources doesn't just go to those who have the most money or who are the loudest or who have connections, right? And that's a part of healthcare that just is a way that has functioned over time. Only the lucky, right, get care, or people who have the most resources. So I think this idea of having some evidence that shows us who should get care when is going to be able to distribute the resources in a more equitable way and also a more efficient way.
Yeah, I absolutely agree. So here's a question. Do we know whether potential bias from AI algorithms is greater or lesser than bias from humans delivering care?
I love this question.
Yeah.
I mean, I'm not necessarily up to date on the literature, but like intuitively, I feel that that's a really important question. And like we point out the flaws of these AI algorithms on this bias and 10-point worst performance. It's like, well, what about humans? Humans are incredibly biased, and it just makes me wonder. It would be really cool to see a study that designed that examined that, but I think it's absolutely true. I think humans are incredibly biased. It's just that AI could possibly accelerate and amplify that human bias, and that's a concern. And if we put the guardrails on, that we can actually have AI for good to try to remove human bias. And I'd love to see how AI could be used for that, because a lot of these are like kind of these scary dystopian stories of how we're going to make it more inequitable. But I actually think if we can encode it to be more equitable, and we can possibly safeguard humans from the biases of humans. So anyways, I think it's a fascinating topic. I'd love to hear what other speakers think, or others from the group.
Yeah, please.
Yeah, I mean, it is interesting how our gold standard is whatever is done in practice by humans, right? And we talked about how we should never use utilization as a metric, but even the outcome could be a biased outcome depending on the treatment care that they received, similar to who is coming in for the Hep C treatment or who's going to get the care first. So it is interesting that our gold standard is human behavior, which has potentially a lot of biases in it.
Yeah, there's like this. Have you seen that JAMA pediatric study? I think it was done in Georgia or something, where they looked at how likely were doctors to prescribe opiates for appendicitis in children. And this was not AI driven. This was just how do humans treat black people versus non-black people. And they gave way less painkillers for the black children than they did white children. And like, wow, that's pretty biased, right? I mean, I think if we did more and more studies like that, we'd show that like humans are incredibly biased and may perpetuate inequity. And if we could encode in our algorithms, like maybe we could actually do it for good, right? And that would be a great condition.
I was actually going to comment on that and about the sort of potential for using AI to improve health equity.
Right.
Because right now, yes, and unfortunately that type of bias exists in a ton of places around, racial bias, cultural bias, and the care that's being delivered. So I absolutely agree that if we can start using these algorithms to shed light, we're not, it doesn't become such a scary thing anymore.
I have one quick comment
Yeah,
on the two.
please.
I think it would be great to take the study that you just recounted and do a simulation and just ask providers, would you apply this AI algorithm to this patient or not, right? Like right now, the algorithm's being applied, but the provider isn't deciding, right? We could look at the bias and the application of the AI algorithm to a patient also. I don't think that's something that we discuss as much.
So we'll do one last question, and this is for the whole group. And I think this question actually came from Akbar, so I'm gonna send it right back to him. So when we think about the research pipeline or even like the translational pipeline, where we're thinking about retrospective, prospective, interventions, evaluation, implementation, in thinking about AI models and also things like cost effectiveness, impact analyses, where do you think that type of work falls on that continuum?
Are you answering your own question?
Yeah, I'm waiting for you, for the experts to talk about it.
Could you repeat it one more time? There was a lot in there.
Yeah. So if we're thinking about like a pipeline of, so research starts with sort of maybe retrospective studies, and we move to prospective cohort studies, and then, we're going into interventions and evaluation and ultimately implementation science, and beyond that, policy work.
Yeah.
where would you think that this type of work, like AI, falls in that continuum? And also, where do things like cost effectiveness come in and impact analysis come in?
Like, would you be looking at the impact analysis and the cost effectiveness before we start down this process? Do you start evaluating midway through the process? Because part of this is thinking about the resource utilization or the risk benefit of this. And does that come upstream or does that come downstream? And again, I'm just curious to see what people think.
Well, I think it should come in multiple parts of that stream,
All the
right? Like
streams.
throughout. But I wanted to call out one specific thing that we've been talking about is understanding better the cost of implementation in relationship to the cost savings. Looking at those two things in relationship to one another over time, and how long will it take to kind of make up the cost of that implementation in the system, which we hadn't been doing previously within the context of the clinical trials, but we're working more with economic analysis in our group.
And then also kind of looking at unintended consequences. I mean, obviously good study design could look at that, but I keep thinking of like lung cancer screening. You see in like those papers, people are doing lung cancer screening studies all the time. And yes, they're saving lives, some, but then it's like all these false positives and like what are the implications for those costs to the healthcare system?
Absolutely.
And not just financial, but emotional, psychosocial impacts to, you know, to patients and burden to the healthcare system. So I think, you know, every test, it was one of your quotes, I think it was your presentation, doctors and scientists know about, no test is perfect, but I think we have to kind of incorporate that in how these models work, because none of them are going to get AUCs at 99.99%, right? It's like these 90, and what are the implications when you do that at scale for millions of patients? I mean, that has major implications from a health policy standpoint.
Yeah, I agree. I mean, I think that sort of similar to what Barbara said, I mean, we need to really be evaluating these things all along the way. And the importance of costing out what it takes to implement something is it's so critical, because if we don't have those types of data available, health systems are not going to say, hey, yeah, let's do this. Let's make this part of our care. So we need to be able to demonstrate that it's actually saving money or breaking even, at the very least. So,
I think one of the experiences that I've learned too, and I agree with you that we should be assessing it throughout the pipeline, but sometimes the best model that I think is most beneficial is actually not what the community wants. And so where I sometimes think that maybe we engage the community early on, at least to see what the potential impact could be, is to engage them early, because they're going to be your champions. They're going to feel like it's most useful. And that's in a way how you gauge the impact, is to have those discussions early before you develop the prediction model, because I can think of a variety of different prediction models that interest me, but the question is that's actually deployable and is the uptake from the community?
exactly. Yeah, I deal with the same stuff when I work in the community in and around Detroit, Southeast Michigan. So it's not just a global health issue about low resource settings, but one that's right here in our backyards too. So with that, we're going to wrap up.
Mike had one more comment.
I have
sorry,
one
go
question,
ahead.
if we have time.
Yeah,
I know, it just
we have a
made
ton
me
of
think
time.
about like signal to noise and governance, like this topic. And one that I think is interesting, we don't have to answer, just to plant the seed in everyone's head, is the oversight and ethics surrounding patient-generated health with continuous monitoring the technology, like your Apple Watch connected to your cell phone, and these healthcare systems now doing all this monitoring and AI-enabled tools. Oh, you might be having an arrhythmia, and we're going to ping the healthcare system. Who the healthcare system is going to be responsible for that?
Right.
And the medical legal ramifications of it, and patient care and ethical responsibilities around it. I think it's going to be a big, it's different than what we were focusing on here. It's like a completely different challenge at scale, and it's coming. It's coming. It's I don't know. I've been
there's
kinda
already
struggling with
there's
that.
already tons of studies
Yeah.
on that,
Yeah.
and those studies are very, very difficult to carry out because of that exact reason. It's like,
Right.
okay, we're going to have this group of people wear this watch, And then they have, all of their data is going to come back to the research team, so to speak, if they're doing a study. And then the research team doesn't necessarily know how to handle that or who to contact in the healthcare system. So yeah, it is coming sooner rather than later. Any last words? Okay. Well, with that, thank you so much for a great panel. And I would just like to thank all of the speakers today. We learned so much from all of your talks. I'd also like to thank the audience. All of you hung around for like almost the whole day, so that's fantastic. Your participation was great. And I'd also certainly like to extend our thanks to the Collaboratory and MIDAS planning teams for all of the work that went into carrying out this event today. So thank you. I do want to remind everyone that the recordings and other materials are going to be available, and more information, you're all going to get more information in your emails in the coming days with links to the recordings and slides, I'm sure. In case you haven't seen the QR code, there's a QR code on the agendas. If you scan that with your phone, that's going to take you to an evaluation survey that we would like for you to fill out. So please take a minute to do that. And finally, for anyone who would like to hang out until about 3 o'clock, please do so. People will be around to network and answer questions. So there's still some soft drinks and coffee and things if anyone wants anything. So thank you again. It's been a wonderful day.